Hi everybody, let's get started with section 0.6. It's about trigonometric functions. In this set of videos, we're going to learn about radian measure, about graphs of trigonometric functions, about periodicity, about the even and oddness of trigonometric functions, about the transformations of trigonometric functions, and then finally about inverse trig functions. So we get started in this video with radian measure. Just one new vocabulary here. It is radian measure, no new theorems or rules. So we start with this. The radian measure of the angle ACB at the center of the unit circle, see the figure below, equals the arc that ACB cuts from the unit circle. So let's take a look at this diagram. The middle circle here is the unit circle. Here is the arc of the unit circle that is cut by the angle ACB. So the measure of the angle ACB in this case is theta, and that theta was defined as the arc that was cut by the angle. But if we go down below, and I'm going to say here, and this is in radians. So I'm going to say down below here, the value of theta can be found from any other circle, however, as the ratio S over R. So let's take a look back at the diagram again. Here is S on a circle that is much larger than the unit circle. S stands for the length of the sector, or arc length, arc or sector length. Now, R is what we know it is the radius. So here we find out that theta can be found anytime, theta in radians, by taking S and dividing by R. So theta in radians is equal to the arc length over the radius of the circle. Okay, so with that in mind, here's an example that uses this. Find the length of an arc subtended on a circle of radius 3 by a central angle measure of 2 pi over 3. So here's a diagram. Here's the center of this circle. The radius is 3. And we want to look at an angle measure of 2 pi over 3. So I know back to my unit circle days, this would be about 1 pi over 3. So about 2 pi over 3 would be in this area. So here is the angle measure, 2 pi over 3, and we are interested in the length of the arc subtended here. That wasn't a very good circle there, but let's try this again. Okay, perfect. So here's what we know from the previous slide, that this angle is S over R. So in our case here, we may even want to rework this equation so that it's solved for S. That's what we're trying to find here, the length of the arc. So this would give us S is equal to R theta. So for our case, S, what we're trying to find, length of the arc, would be equal to the radius, which is 3, times the measure of the central angle in radians, which would be 2 pi over 3. And that's going to give us an answer here of 2 pi. So that length for this particular circle would be 2 pi. So we move on a little bit more on radian measure. When an angle of measure theta is placed in standard position, now standard position means that the initial ray is on the positive x-axis and begins at the origin, and then the terminal ray moves counterclockwise from there. Of radius r, the 6 basic trigonometric functions of theta are defined as follow. And you know these: sine, cosine, tangent, cosecant, secant, and cotangent, where sine would be y over r. If you see your right triangle in here with your acute angle theta at the origin, then you can kind of think to yourself that y looks like the opposite side, x looks like the adjacent side, and then the radius of your circle would be your hypotenuse. And in that case, sine opposite over hypotenuse would be y over r. cosine adjacent over hypotenuse, x over r. Tangent would be y over x. Again, opposite over adjacent. And then their reciprocal functions, reciprocals, here would be r over y for cosecant, r over x for secant, and x over y for cotangent. So now we have defined not only radian measure, but all 6 of the basic trigonometric functions.